Okay, so what I've done is I've poured distilled water into this beaker, okay? What we're going to see is we're going to combine this water with something else. And the item that we're going to combine it with is dry ice. Now, dry ice is just regular CO2 that it has been solidified. So CO2 in solid form. So we're going to drop a solid object into a liquid, okay? But we may not know whether or not a reaction occurs. In fact, I can tell you this right now, that if we were to just drop this solid CO2 into the liquid, that it would not create a reaction that we'd be like, oh man, that's definitely a reaction. Here's the evidence. And you would be able to point on all of your fingers like, this is a form of evidence, this is a form of evidence, this is a form of evidence. All the different types of evidence that we've talked about, you would not be able to use because you would not be able to see it. So in chemistry, some things have to have something known as an indicator added. Now this indicator is called universal indicator, and it's added because we cannot actually see what is being created. And that is your goal for Friday, is to tell me what this question mark is when we combine H2O and CO2. So I'm going to show you a little demonstration with this, okay? I'm going to add a base to this to make it look a little bit more, so we can see more color change when this occurs, okay? So when I add this clear solution, this is another reason why we need to make sure everything's properly labeled. Notice this looks very similar to this water. It's clear, it has a lot of the same properties, however, the chemical properties are different. So I'm going to pour this in here.
Is it poisonous?
Yeah, it's sodium hydroxide.
Oh, is it poisonous?
Yeah, it's poisonous.
I'm going to take this and mix it up. Okay. Then I'm going to pour some of this indicator in, and we should see if it is neutral, it'll be like a green color. If it's still a green color after I pour it in here, then I'm going to add more of this base to it. If I've added enough of this base to it, we should see that when I pour this in, it turns a purple color. Okay, so I'll just go ahead and add some. Ooh, it did. Beautiful. As predicted. This is why you should listen to me, okay? All right, next thing. I'm going to take some dry ice out, okay? And I went ahead and bought this morning. Dry ice is an amazing substance. It's very cheap. You can do a lot of fun things with it, especially around Halloween. But I'm going to drop a little bit in here. I'm going to have to pick up some more for tomorrow because dry ice does not stay around a lot, just because it breaks down. So I'm going to use my other glove. You know what? We're just going to stick the whole thing in there. Why not? Okay?
Let's do it.
So when I put the H2O, right now we currently have H2O and indicator. When I put this CO2 in here, there will be a chemical reaction that occurs, okay? And so we will see this. I'm telling you this right now. There's a chemical reaction that's occurring, but you have to figure out the product. So this is beautiful, right? This is a beautiful color. You know, I would love to have that in my wedding, maybe, okay?
Yes.
I don't know, okay? But then I'm going to drop this and watch this. Wait for it.
You made a potion.
Look at it. What is it doing?
Turning blue.
Colors. Can I go and touch this?
This, ladies and gentlemen, is why chemistry is amazing.
Can I touch this?
Now, watch it. It'll continue to go on for a long time. We'll get into an orange, and then we will get into a red. Red indicates that we have created an acid. So what we've done is we went from a base
It's orange.
to an acid, and we went through these different scales. And what's going on here is as this new product is being created, it's making more and more of this substance, and it's causing there to be a chemical change. You can't see anything forming because to our eyes it's so small, but the indicator can detect that something's going on. And it may take a while for us to actually get to that really dark red color, but this is a great example of a chemical change, and we're using this indicator to detect this, okay? The next thing that I want to show you is using magnesium shavings. And magnesium reacts with oxygen, but we can actually cause this reaction to occur a lot quicker if, for example, we put it under a flame, okay? This is why we actually have to have magnesium in a sealed jar, because it will still react with the oxygen that when I open this container up, and that's why it looks tarnished right now. Most metal can actually react with oxygen, and it will at some point, but this is just a great example of this. So I'm going to go ahead and hold on to this with a tong, and I'm going to tell you this right now, be advised, that when magnesium reacts with oxygen,
It sparks.
we have Mg, and this is a solid, and when we react this with oxygen, O2, as a gas, we end up creating something new. I want you to tell me what it is that you create. So here we go. Do not look directly into the flame. When someone says that, what's your most likely action? To look into the flame. I'm telling you, please don't, okay? Oh, come on, you were working just last period. There we go. I'm gonna have to get another one of those.
Looking at the flame.
Yeah, but once this gets going, don't look at it. And here it goes.
It's really bright.
Super bright. Okay, now also look up here. What do we see here?
Smoke.
Smoke. Was that a form of evidence that we have that a chemical change has occurred?
Yeah.
What's another form of evidence that a chemical change has occurred that happened with this? Huh? A light. What's something else? It gave off
Light.
light in the form of heat, yes, or energy in the form of heat, energy in the form of light, absolutely. So these are examples of chemical changes. They are easily seen with our senses that actually has occurred, that a chemical change has occurred. If it were not for the universal indicator, would we have been able to determine that a chemical change had occurred? No. So what I've just shown you is that some reactions we need help determining this, and others we do not. Okay? So I'm going to go ahead and write down for here, forms of evidence that this actually formed a new substance was that we had heat, we had light, and we had smoke.
Can we do it again?
We also created a new substance, which is right here, this little powder material that's white, okay? New substance. That new substance is what you're going to look up, okay? So it's a new substance.
Ash?
So for Friday, I want you to tell me what's going on with this, okay? And then when we come to class, I want you to share out, or share with each other in small groups, and then we'll share out as a whole class. And then you'll get a small little assignment, okay? Any questions? Done.